Hello. Hello, Eric and Ryan.
Hello.
Okay, so today we're going to talk about another data structures. So, can you tell me what kind of data structure have you learned in the past? Remember we got the queue, yeah?
And stack. And towers. No,
and stack, yeah? And a list as well, yeah? List, yeah? These three kinds of things can all be represented in Python using this bracket, yeah? Yeah, square bracket. This is square bracket, right?
Yeah.
Yeah? Okay, so today we're going to add another data structure. So remind me, what is data structure? It's the structures to hold data, yeah? So we need to let computer to hold data, so then the computer can process the data, am I right? Yes? So we're going to add another data structure called set. So can you tell me what is set?
I don't know. Set up.
No, set up. Okay, set is a collection, but only with the unique data. Okay? Do you understand? Unique data. So for example, like, okay, so if there's a bunch of data, 1, 1, 2, 3, 4, 4. Okay? So look, there are duplicate elements, yes? Duplicate elements. Ryan? Duplicate, there are 2 4s, 2 1s. So this is you can have a list of that. But the set will only, if we convert it into a set, it will only contain 1, 2, 3, 4. Okay? Do you understand? Because these are the unique elements. So how can we do this? Look. So look, if we have numbers, nums, yeah, equals, we're given a list, okay? List 1, 2, 3, 3, okay? That's it. And now we're converting it to set. So how can we do it? We can do this. Let's call it n, okay? N equals set. We use this keyword set and bracket. Yeah, you can create the empty set by doing this, right? You can create the empty set by doing that. Or you can take a parameter with the list, yeah? Numbers. So what do you think will happen? Now the n will contain 1, 2, and 3, okay? And the set is unordered. It means that it's just a collection and you don't know which comes first. But it tells you those are elements which are unique. Okay? Got it? Okay, so now look, we can do this.
That?
It's simple, yeah?
Yeah.
Okay, so let's introduce another graph called Venn Graph. This is interesting. Venn Graph. Okay, so basically, let's say we have a collection here, A. Okay?
Yeah.
Collection. And here we have another collection, B. Okay, so this collection, we can call it, we assume it's unique, so we can use a set, A set, B set, okay? So now, A set, B set. So A, let's use this one. A equals set, okay?
I can't see.
A is a set. Okay, A is a set with some animals.
I can't see with your own.
Okay, B
Eric can't see.
equals another set. Okay? So now, what's this part? What's this bit?
C. Both A and B.
Both A and B. So the element both in A and B. Okay? So we can use this A and B. This will give these elements here, right? So you can write it this way: A dot intersect B. Okay? A and B. So you will return this part. So for example, A is 1, 2, 3, and B is 2, 3, 4. A and B will return 2 and 3. Yeah, because 2 and 3 appear in both graphs. Okay?
Oh
Yeah. And how about all together? So A plus B. Not plus B, actually. A or B. Okay? It's all, it's a single. A or B. A dot is the same as these two are the same. Okay? A dot union What's the meaning of union?
I don't know. I know.
Union. Union. I union you, so we put it together. So look,
No, I
A,
know.
B, union together, that will be, what's the answer of A union B? A or B, what's it? It will be 1, 2, 3, 4, okay?
Mhm.
So all elements from both sets. Okay.
1, 2, 3, 4.
How about, look, this is interesting.
1, 2, 3, 2, 3.
How about, I want the elements not in common, so is this bit or this bit?
This bit.
So that we call it what? We call it A,
Plus B.
now A exclusive, so we use this symmetric difference, okay?
Symmetric. What is symmetric?
So maybe,
What do you mean by symmetric?
so how do we do this? Is A dot symmetric difference. Okay, B. Symmetric. I don't know how to spell it, but you know this meaning. Symmetric. A, we call it exclusive. So this will
The
return.
same on both sides.
No. You will return all elements which are not in common in both sets. So you will return what? 1 and 4. Okay, 1 and 4. Okay. How about A minus B? Can you tell me what is A minus B? So it's in set A, but it's not in set B. Am I right?
1.
Yes. So we return 1. Okay, that's a return 1. And the opposite will be the same. Okay, so we can do this. A smaller or equal to B. We can say if A is a subset of B. Okay? Or B if it's a subset of A. Look, any set is a subset of itself. Okay, because there's an equal. Right? Yeah. So if we remove the equal, then you will exclude the equal case, which is that it's a strictly subset of another one. So how about if we want to check if two sets have something in common?
Just happened to my watch.
Yeah. What do you know? How do you know if there are two sets have something in common? So look, we can use this one, right? A and B, and we can check the length. Yeah, that's one way. The other way would be A dot is disjoint B, okay? If there's anything in common. Okay? So this is the set data structure. And we can add and remove it. So for example, we can do this. We have this set, we can say A dot add another one element, like 5. After this, A will have 5. Okay? Everyone, and we can remove it. A dot remove 5. Then the 5 will be removed. Okay? Okay? Do you understand? Okay, so this is the basic operation of using how we use the set in the Python. It's actually very powerful. Okay, so how about if we want to okay, so let's do this. Okay, if I give you a string, A, B, C, you need to return true, because all the numbers, all the characters in the string are unique. Okay? But if it is A, B, C, you need to return false. Do you understand? Because the A is not unique. It appears twice. Got it?
So if it appears twice,
Yes.
it's false.
Yes. Yeah. So how do we do it? How do we use the set to define this?
Def.
Yeah, I know. Def. That's def. Let's write it. Okay.
Define.
Let's write.
Could you go a bit slower?
Define. Let's say
Could you go a bit slow? Because I'm trying to write it when you say words.
Don't worry, you got plenty of time afterwards. Okay, listen carefully and then you write it. Practice. Define. How do we call it? The function.
Venn graph. Set.
Unique. Let's say unique. U-N-I-Q-U-E. Unique. String. Okay, a string. And what's missing here?
Column.
Yeah, that's the answer. You always get it right. So, so how do we do it? We can have different ways of implementing. For example, we can do this. Okay, the easiest way, the most intuitive way would be I create a set first. Okay, let's create let's call it what the st. Okay, set. It's equal set. We create a set. Okay.
ST.
Then what do we do? We can iterate the function for I in S. Okay, then we need to do this. If I is, so how do we check if a set has some we can use this, right? If I in set, right? Can we use this? If I in set, then we return false. Otherwise, I will put this st. I will put it at I, and otherwise I will return true. That's one way of doing it. Okay. Let's see if it works. Okay.
S.
Let's see if it works.
Wait. Be quick.
Yeah, if it's working.
What? Daddy.
Yes.
When I enter, look what happened. It doesn't even work.
Okay. Wait.
Space. Oh. Oh yeah, I forgot something.
Yeah.
I actually forgot something.
Okay. So this is one way of doing it. We're creating a set. Look, we check if this integer, if the character is already in the set. If it's not in the set, then we return false. Otherwise, we put it in the set. Then, so to get it. Yeah. So this, look, A, B, C, then we return true, right? Because every time it's only appearing once. But A, B, C. Look what happened with A, B, C. A is not in the set. I put it here. But the next one is already in the set. We already put it in the set. Then we return false. Do you get it? Okay, how about the other way? We take these, we take the whole string and put and build a set and then check the size if it's the same as the string size. So it will be even simpler. So how do we do it? Yeah, we can do this. This is the same. Unique. So we build a set. We build a set. And we need to take the S, build it, okay? And then how do we do it? We just return S dot size, not size, length, st equals len S, right? Do you get it? Look, we're building this. If we build a set using this string, using these characters, then the set will have three elements. They're unique, right? So this is true. But these, if we build a set using these characters in the string, the set size will be 3, but the string size will be false. They are not equal. Am I right? They are not equal. Eric, do you understand? So you see, this is one quicker way of doing that. This is the traditional way of doing that. Checking if they are duplicate. If this string contains only the unique characters, okay? Do you get it? So which one do you like best? Which way do you understand? Which one?
That one.
This one is more easy to understand, yeah?
Yeah.
Okay, but this one is cool, yeah? It's just one line, yeah? Okay, 2 lines.
4 lines.
Okay. One, no, this comes there. I mean, this is one line. This is one, 2, 3, okay? Ryan, any questions?
No.
Does it make sense?
Yeah.
Okay, good. Okay, thank you.
False.